Okay, so I have the hard task to be the last presenter. So I hope you still have a little bit of attention before going for the drink. I will present to you this CartoNat project and connected research project that will involve the French Forest Service with Rémi Savasi, who is the co-coordinator of the project with me from INRAE, which is the National Research Institute for Agriculture and Environment. So there are a lot of colleagues from my institute that are involved, but also colleagues from the French Forest Service, from the Météo France, 3 of them are in the room, colleagues from the Geographic National Institute, and other research colleagues, including Bati. The context of this work is that after the catastrophic 2022 season in France, there was a new law that leads to specific requirements in terms of hazard mapping for the entire France in order to do a classification of forest massif, to map the sensitivity to predictable risk of fire and crop fire, forest fire and crop fire, to identify the most exposed cities and the danger zones. And that should also account for climate change because most of the exceptional fire occurred in areas that has not experienced a lot of fire before. So the government has already existing projects at regional, at departmental or communal scale, but they are highly heterogeneous. So here there is an example of map for a department in the southeast of France. And the method were not straightforward to extend to a national scale. So the government asked to a private company to provide an IA-based solution, but the project was not successful. So the government finally changed the approach and rely on its operational services and state operator to do 2 working groups, one to define the needs and one to define what were the technical possibilities and method. With the state operator listed here. And the idea is that at the same time they work on the technical specification and an analysis of possible funding. And so this process took 2 years in a highly uncertain political context. But finally, the project really started very recently, in fact. So it's a quite important project for 3 years. And we already have some seed money to do early start, which is why I will already have some elements to present to you. The main requirements are to be consistent among territories and to map fire hazard at the national scale, which is really ambitious. We should address both forest and crop fire at a resolution that allows to address reglementation issue, so quite high resolution, and to include climate change. And in the end, even if the main focus of the project is to map hazard, there is also some perspective to adapt the tools built during this campaign to operational forecast. So the modeling is relatively classical, based on occurrence, so probably of fire. We already talked a lot about this today. And the intensity, the potential fire line intensity, which can typically be addressed at daily or hourly scale, which is danger. But as I said, it's not the main focus on the project on the short term. On the short term, we should work on the reference period to map the fire hazard. So I will first talk about the fire occurrence mapping, and then I will talk about the fire line intensity mapping. So the approach for fire occurrence is based on a model called fire livelihood, which is very similar in concept to what Francesca showed before. It's a statistical model that is can be used to map the occurrence of fire of different size, because we initially modeled the entire distribution size at a relatively coarse scale, and it is based on observed past fire, fire database, and some predictors, typically fire weather and land use, land cover, as explained before by Francesca. So this approach has been developed since 2017, initially mostly for the southeast of France with a quite detailed model with the aim of anticipating climate change impact. But in fact, there are some applications for forecasting spread days, as shown before, and also to map hazard for typically when you apply the model to 20 years of weather condition. Just to illustrate the model, some of our recent work done for southeast of France, where we separate the effects of different weather variables. So here you have the effect of wind speed on the probability to get a fire. Short-term indices like vapor pressure deficit and fine fuel moisture code, depth moisture code, and DC. So as you can see, the response to the different variables are really different, and they can be estimated altogether thanks to the approach. We also applied the concept to Europe using the FIS data, building a model to estimate the probability to get large fire and the probability for fire larger than 100 hectares to go to 5,000. And I will not go in the details of this, but we showed that the drivers are not the same, and that, of course, land cover is also crucial to get relevant prediction. Just to illustrate, because it's not the focus of the presentation, we can build some probability to get large fire at the European scale, and some probability to get extremely large fire, larger than 5,000 hectares at the European scale, and they don't match with FWI because there are other factors involved. And also in collaboration with Francesca team, we also tried to test the model in terms of forecast with here you can see how the precision goes lower with the lead time, even if the model is always superior to FWI itself. So this was just to illustrate what we can do with this approach, and it is some way complementary to what Francesca did. In the frame of the project that I mostly talk now, the objective is to map fire activity in France and to anticipate the effect of climate change. So we start from previous work we done for the government, where we used a very simplified version of fire livelihood applied to fire larger than 20 hectares at an 8-kilometer scale. And we did this map of activity that can be used to anticipate the effect of climate change under different degrees of global warming. So you can see both the intensification and the expansion. And the model is really simple because it's based on mean seasonal FWI and a fuel map, an expert-based fuel map from French Forest Service. So in the CartoNat project, we expect several improvements from this basis. First, we will use a final resolution, which will be not very high resolution, but at least sufficient to do classification of cities and forest massif. 8 kilometers is not enough to do so, but 1 kilometer is satisfactory to do so. And for that purpose, we use much finer weather data. You can see here on the Alps, before we were using 8 kilometer resolution data, and now we have 1 kilometer resolution data, which are much more appropriate for mountainous region. And from this, we have this prototype map, which is at the 1 kilometer grid, which is already an improvement with respect to the previous map we were showing before. We expect other improvements in the project from the land use, land cover data. Initially, I mentioned that we use this sensitivity map from ONF of vegetation that was aggregated at 1 kilometer. within the project, we have a much better resolution land cover map, which is a co-production of French Forest Service and National Geographic Institute. It's a 10-meter resolution, and I'm sorry it's in French, but there are all the classification of land cover in terms of deciduous trees, grape, grasslands, shrublands, etc. So this is an example of this land cover map. And here, this is the fire, Ribaud fire, the very large fire that we experienced this year. So this map is really interesting because it's much more detailed than before. But if you want to use it in terms to predict, to estimate a model, a statistical model of fire activity prediction, the problem is that the map is most often posterior to your fire data. So it cannot directly be used to adjust a model because, for example, in this fire that occurred in 2019, of course, the map that we have is posterior to the fire, so it's not relevant to use for model estimation. And what we did is that for all the, well, it's still on progress, but we have done most of the work. We have used machine learning with XGBoost and Sentinel-2 and Landsat data to reconstruct the land cover map on each fire, how it was before the fire. And you can see, for example, that of course there was much more pine species before the fire than after the fire, where it has been replaced by shrublands mostly. So this map, this new land cover product will be used to estimate much better effect of fire selectivity for fuel types, and it's connected to other research projects too. And we will also incorporate in the model other land use variables such as road density, wide-land open interface, and also other predictors from the Greeneo project that Jan will present tomorrow. We also expect other improvement of the fire occurrence map based on regionalization of statistical model, because we have already noticed that many responses are not the same over the whole region. For example, a response to forest area or slope may vary with the bioclimatic region. And we will also use alternative model, especially spatial models, to improve the model. And the previous Firelihood model was based only on forest fire. We will also develop a specific model for crop fire based on our land cover map, which account for crop fire for agricultural land cover, but also thanks to a specific database that has been compiled from press analysis at the communal scale, because the database that we have for crop fire are not complete in France. And we will also use specific predictors coming from the agricultural world that will help to model the serial senescence in time and space, which is a critical factor of crop fire. So this model will be completely new. So these are the improvements that we expect from our occurrence map, but we also need much finer resolution products regarding the intensity. The occurrence map allows to know at the regional and national scale where the fire will be, but once they are here, we need to know at a high resolution what will be the potential fire intensity depending on the neighboring fuel. So we will rely on, of course, terrain, current and future weather, land cover map, and structural parameters of the fuel that will be derived from a national line of flight that we have that cover the whole territory. And so regarding the weather, I will describe later how we define some reference weather conditions that will be used to buy the potential fire intensity map, how we estimate the moisture content corresponding to this weather condition, how land cover and LiDAR metrics can be combined in high-resolution fuel maps, and how all these variables, including terrain, can be combined to estimate a potential rate of spread in reference condition and crowding activities to finally derive simply with Byrne formula an intensity. So regarding the reference weather condition, the objective is to develop a methodology to propose for each region reference weather corresponding to representative risk. There are lots of existing approaches that has been used to do this work, mostly based on wind or observed past fire, but none of them is applicable at the world territory and can account for climate change. So we propose a new method that is based on 3 steps. The first step is to do a selection over the last 20 years of fire days at risk, and to segmentate them in terms of wind direction and level of fire weather. From this, we will use spatial units in which day at risk are relatively similar, because the weather scenario should be developed for a given representative area, so we cannot propose reference conditions that are not consistent within an area. So for that, we use some fire zones that are used operationally by Météo France. And in fact, we already showed that in most of this area, the day at risk are more or less the same. So from this, you can select your day at risk in the past years and do some clustering to build some reference weather condition, simplified of course, but representative of the risk. And they will be evaluated from local products that we already have, and some with some dry wind rows produced by Météo France. Once we have this reference weather condition, we need to derive some corresponding fuel moisture to put in the fire models. So regarding the dead fuel, we expect to use available empirical weather based model. Regarding the live fuel, we have several options. First, initially when the project was started, we only have this product that we developed, which is XGBoost modeling based on weather data, MODIS shrub cover, and soil map moisture content that was adjusted on the operational data set of live fuel moisture content that we have, that can be used to evaluate the condition. But in the meantime, the colleague will present it tomorrow. We have now another product based on deep learning applied to ISBA output. Jan will present this tomorrow. And we have other alternative from an NR project that will see how we can use thermal infrared and radiative transfer model from optical reflectance to estimate live fuel moisture content. And we also have some ecophysiological approach, but I will not go in too much in the detail. So once we have our moisture and wind and weather condition, we need of course the fuel map. So I already mentioned this land cover product, which is based on the IA and some post-treatment. And we plan to combine this information with the LiDAR data. So the first step is to simply use some estimation of tree cover to refine the land cover map. Typically, in the land cover map, we have either forest area or shrubland, but we know that reality there is a continuous of situation, and so thanks to LiDAR we identified zone with tree cover between 10 and 50%, which can be qualified as woody area rather than forest or shrubland. But we can go much beyond that with the LiDAR data, because from the LiDAR point cloud that we have for world France, we can derive some vertical profile of bulk density in 10 meter pixel. So this is some work that was published last year in Agriculture and Forest Meteorology that can be used to estimate the fuel load in the surface fuel and the LiDAR fuel load, the crown base height and the fuel strata gap, and the canopy fuel load. So typically, still on my Reboat fire, I plot here some fuel map of some map of canopy height, fuel load in the 0-1 meter layer, and canopy fuel load, but we can have other metrics. So unfortunately for us, half of the northern half of France was measured with the LiDAR in leaf-off condition. So we need some correction of the profile where we are in deciduous trees. And we are quite lucky because in the Geographic Institute, National Institute, there is an ongoing PhD working on this topic. And so we will work on this. I hope it will give satisfactory results. And then from that, we will produce the LiDAR data in 3 different data sets. The first one will be within the fire perimeters, and this will be used for model evaluation. I will comment this in a minute. We will also produce this LiDAR data first in some prototype region, because for the occurrence model, we address the problem at the national scale directly, but for this high resolution map, we cannot do that. So we will select a number of fire zones on which we will work for prototype maps. But at the same time, the Geographic National Institute will compute these metrics for the whole France. So it's a huge quantity of data because it's 17 pounds per meter square, and they have to do the whole France. So they will do this during the next 1 year and a half. And I will skip the next. And my last point is how we combine the weather and moisture and fuel data. So probably here some colleagues will be disappointed because the plan is to use some simple point functional model that will just locally assume that a fire comes and try to estimate a potential fire intensity given the data we have. I have done the first year of my career working with physics-based models, so I know that it's probably not the best way to work, but the truth is that we have to work in a relatively limited timeline, and so we cannot do better than that. What we should do about that is that currently most of the fire hazard map that are done at department scale are done with approach like that, and sometimes even much simpler than that. So we will use the help of several expert colleagues to help us to select this point functional model for our different fuel types and how to link them with the LiDAR data, especially. And we have a plan to evaluate the approach by simply reapplying this modeling to the past fire, because we have a data set of land cover and LiDAR on something like 200 fire and land cover only for more than 550 fire perimeter. So we will apply the modeling chain to this fire and compare the output with some, for example, the crown potential with field and satellite severity. We will also use the FRP from second generation and third generation of Meteosat mostly to get some temporal info on the fire. And we will also rely on the expertise of operational and on the observed spread rate. Those we are already available, and those typically produced by Uber. Just to show what we plan to do, typically on the Sijan fire that was mentioned by Cyril this morning, this is a map of fire severity that can be compared with output of here. This is Rotormel model. This is CEFIS, and we plan to use all of them and eventually to recalibrate them if the results are not satisfactory. The project timeline, I mentioned it, is really short. We mostly rely on staff member to ease maintenance and future updates, because this project is on 3 years, but there will be some updates of this national map. Regarding the occurrence mapping, the lead is INRAE, my institute. It will work on improving this first forest fire occurrence map that I mentioned before. I also mentioned the crop fire, which will be brand new, and we will do some projection, climatic projection, near the end of 2027. Regarding the intensity mapping, the lead is from the French Forest Service. We will mostly work on prototyping the map in the selected fire zone and for the evaluation on past fires that I mentioned just before. The production for entire France will be done by French Forest Service in 2027. And as I mentioned it will rely on the geographic LiDAR metric computed by the Geographic National Institute. And then the two information, intensity and occurrence, will be combined by the French Forest Service, and this application will be done at massive and commune scale. And the last part is that because most of this work can be also useful for operational, typically the fuel map, but not only. We will try to adapt these tools, which are here designed more to be accurate at the spatial resolution, but we will adapt them for operational forecast with a specific focus on hourly or daily scale. And this will be implemented by Météo France in complement to already available. So my last slide, sorry. And after we can go for a drink. Conclusion and take-home message. So it's a specific project because it's funded by the government. It's not really a research project, even if there is lots of research inside. So for state and operational service, we expect to produce for them projects that are consistent. The three ministries in charge of fire risk are involved in the monitoring on the project, and it will provide for the first time the best data in terms of land cover, weather, and available data and available method in terms of science, and can be seen as the first step of a roadmap for all the states operator together from the three ministries, because the law anticipates that this map should be updated every 5 years. So it will leave some room for more science for later. And so regarding researcher, we aim at publishing all these methods in a series of papers in maybe Annals of Forest Science, typically on the same way than the Australian and Canadian forest system are done. There are synergy with some research projects that I tried to mention all around my talk. All the data sets in terms of weather, fuel and fire and models will be made available for other research projects. What we expect is that this work build a good basis to be shared, and so that we can complement this approach and have a good opportunity to organize a little more the research in France. And that's it.